Good morning, Pre-Algebra. How you guys doing today? Hope you're fine diddly dandy. Today, 12.8, we are going symmetry and transformations. So these are basic adjustments that can be done when talking about shapes. There's a few different types that we're going to go over. The first one is transformations. We'll get to symmetry a little bit later, but there are a few different types of transformations, how shapes can, in this case, transform. The first one is reflection. When a shape reflects, it's kind of like the image is mirrored. So here I have triangle DEF and a vertical line, this dotted line here. And when triangle DEF reflects over that line, it kind of flip-flops. It mirrors itself over like so. So in the reflection, it kind of bounces off like that. You guys have probably noticed this when people are taking a video of themselves, but the words are all backwards. Or if you look in a mirror and again, the words are backwards. Well, this is why, right? It looks backwards. Same happens with shapes. That is reflection. That's a transformation. The second one is a translation. A translation is when it moves, but it faces the same direction. So it's the same shape, it just moves. So, for example, that's, again, I have triangle DEF, and it's translating over here. So same shape, same order, same direction, etc. It's just moving. You'll see that a lot. You'll see translations a lot on a coordinate plane. So if I have this triangle, looks like pizza. Maybe I'm hungry. And it's translating up here. Same shape, same direction. It's just moved now. It's translated over. Whereas if this were mirrored across this axis, it would be something like, actually, it would be okay. So this is translation. And this is reflection. Okay. This is the original O-R-I-N-G. Okay. Another transformation is a rotation. This is where you turn it. We've seen this a lot when we're talking about similarities or proportions, where we'll see, so I've got ABC here, and I'm literally just turning it like that, but it's still in the same order. It's the same shape. It's just now in a different direction. Okay. So those are my transformations. Those 1, 2, 3 transformations. Reflection, translation, and rotation. Okay. Moving on to symmetry. So we begin the conversation on symmetry talking about lines of symmetry. So lines of symmetry, again, we're dealing with the same one shape. I'm not comparing it to something else. I'm talking about where I can fold the shape to make sure that both halves are the same. So let me use the same whiteboard, but oh, you know what? I don't even need this side. I can just do it here. So let's say I have a rectangle. So on my rectangle, where can I fold this in order to make sure that the rectangle is the same? Well, if I fold it here, you know, so this is going to erase and it's going to fold down here. Does that match up? If I folded this ear in? No. Right? Because now I've just done that and that looks like it's a shy piece of paper or something like that. No, that's not how it'll work. Okay, so what I can do, watch out, is what if I fold it straight down the middle? If I fold it straight down the middle, it'll be, right, this will flip over and it'll match up my corners. That is a perfect line of symmetry. Now, my other one is down this middle, because now I could fold it again, and this line is going to come over and cover it here. Okay, so my two lines of symmetry are like that. For a rectangle, those are the only two, the vertical and the horizontal axis. If you remember way back to September when you guys watched the video on the skateboard physics, this is the intermediate axis, this is the vertical axis, but you don't really need to know that. Now, the other shape is a circle. And the circle has an infinite amount of lines, right? We could fold it here, 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 as long as it goes through this point of symmetry. So these are my lines of symmetry. And this is another line. So my line here and also my line here. Don't worry about the rotation quite yet. Yeah. Whereas this doesn't have not a line, but a point of symmetry. So circles have points of symmetry, and again, that's the midpoint at the midpoint. Whereas rectangles only have these two lines. Okay. Moving right along. For any shape, there are three potential forms of symmetry. For any shape, again, this is just comparing it with itself. The first one is a line of symmetry. So that's what we talked about with the rectangle, where the shape can be folded across the line to match entirely. So remember with the, if I took this paper and I folded the corner, well, that's not going to match entirely. I would need to fold it down the middle or down the middle here, and that'll match entirely. Here's a few more examples, and these shapes are not our regular polygons, right? So I've got a crescent moon, a heart, and this is an angle. This isn't even a closed shape. However, these can be folded across these points of symmetry. Forgive my imperfection in drawing, but you get the idea. They would be folded across the lines of symmetry to match the other side entirely. Now you might be thinking, well, Mr. Boulder, can I take this piece of paper and fold it diagonally? It won't match up perfectly. Let me just show you. I'll fold my paper from corner to corner. And you see how, although it's folded corner to corner, it doesn't match up entirely. So that is not a point of symmetry. Let's see, let me use this side. Okay. All right. So that's the first one. A potential form of symmetry is a line of symmetry. The second one is rotational symmetry. That is if the shape can be rotated around a point to match itself. Okay. So that would be me taking this guy and rotating it. Link. Oh, yep. It's still matching itself. But it must rotate in under 360 degrees. So you can't rotate it all the way around and say, oh, yeah, look, it's the same. I can't take R2D2 here and say, oh, yeah, it has a point of symmetry, because if I rotate it all the way around, look, it's the same. No. That would be if I rotate it 90 degrees or rotate it 180 degrees. Yes, I have R2D2 on my desk, of course. Of course I do. I have a vampire pencil sharpener. Of course I'm going to have R2D2. Okay. Also, when you talk about rotational symmetry, you must talk about the degrees of rotation. So remember over here when I was talking about the point of symmetry, yes, this does have lines, but this is the point where it rotates for the rectangle. This would be the point of symmetry, and it rotates 180 degrees before it matches itself. A quick tip is to divide 360 degrees by the lines of symmetry. So these guys up here, they only have one line of symmetry. So they do not have rotational symmetry, because 360 divided by 1, well, that is that is not a rotation. That's not a full rotation. Rather, it will be a full rotation. Therefore, it doesn't have a line of, it doesn't have rotational symmetry. That's what I was looking for. Okay. So this is a parallelogram. Parallelograms have two lines of symmetry, right here and here. Therefore, it's rotationally symmetrical. A square, on the other hand, you can go from corner to corner and vertically and horizontally. Therefore, there are four lines of symmetry. Therefore, with a square, you only need to rotate it 90 degrees and it'll match. So here's what it means. I think this will help. So here is my square. And this is the outline. Let's see if this works. Hallelujah. Okay, so this is the outline of the square. Yeah. Okay, right. So that's the outline of the square. How far do I need to rotate it? Right, if this is the top end, how far will I need to rotate it before it fits back in that shape? Well, just 90 degrees, and it maintains that original shape. Now, if I had, let's see, I've got a business card here that is a rectangle. And, oh yeah, something like that. But this guy will need to rotate 180 degrees. See, if it's like this, if I just rotate it 90 degrees, well, it doesn't fit. It doesn't fit the original shape. So it needs to go 180 before it fits the shape, okay? So that is rotational symmetry. The final one is the point of symmetry. A figure has a point of symmetry if there is a center point, like the circle. The intersection of two or more lines of symmetry. Okay, so with the rectangle, again, it was where those two lines meet up. With the square, it's where these 8 lines, where these 4 lines meet up. A heart, however, does not have a point of symmetry because it only has one line of symmetry. So it's the intersection of two or more lines of symmetry. So the point of symmetry would be, again, on my rectangle. So my point of symmetry, that's a really big point. It doesn't need to be that big. Or if I did a square, and I've got right here. Okay. All right, guys. Hope this helps. Yes, it's a long video, but it's a lot to cover. A lot of visuals. Geometry is very visual. If you have questions, please don't hesitate to ask. I will come out with a video for the quiz tomorrow. And otherwise, love you guys a bunch. Bye.